Hello viewers, welcome back to video tutorial on AgentGrid. In this video, we'll discuss about one of the core functionality of ServiceGrid, which is known as functions. Functions within ServiceGrid we'll discuss in this video. And in the previous video, we have discussed one other component known as tools in the ServiceGrid. So in the previous video, we have gone through the GitHub of the ServiceGrid, where we have gone through like we're now on a very high level the overview of the ServiceGrid and its core capabilities. Basically, it has a function bank and tool bank and API bank, and in that we have discussed tool bank, and we have used tools in the agent code, and the tools were local Python implementation of tool. And this is our GitHub repo, Cosmos AI-AgentGrid, where this example is hosted. So in that, you can go to service grid examples, and these are the 4 examples we have lined up. And in the previous video, we have discussed about tool usage demo in the service grid, and these are the libraries. So in this video, we'll discuss about the functions. So in the previous video, we discussed about Python code, tool bank, and we have a binary also, we have not discussed it. And in this video, we'll discuss about the functions bank. So as we told in the previous video, that tools, whatever the tools will be running within the agent code, that is, it shares the CPU cycle of agent, RAM, disk, everything about agent pod. Whereas in the function bank, the functions will be run as a separate entity or a separate pod, and they will not share anything related to agent codes resources like CPU cycle, RAM, and disk. It will not be used at all, so it will be taken from somewhere else. So the functions will be running as a separate entity. It is not a part of a agent code. So in the functions, we have stateful and stateless. The stateful functions are basically Kubernetes deployments, and stateless are basically Kubernetes jobs. In order to provide some more information, so in the functions, there are 3 types of functions. One is type 1, type 2, type 3. And type 1 function we have utilized in tools code, so where the function is registered inside the tool registry, and we pull those Python functions and ran in the agent code itself as a agent's memory space. So that is a type 1. Whereas in type 2, type 3, they are Kubernetes pods. They run as a outside of the agent code. So the type 2 is nothing but the stateless, and type 3 is nothing but the stateful functions. So in order to give a little more extra information on this, so I have a type 1 function, type 2 function, and type 3 function. Type 1 function is loaded and executed within the application, whereas type 2 function deployed as a job in a remote cluster, on a cluster, and a type 3 function can be deployed as a stateful online function. So the descriptions executed within the application's own process using the local function evaluation SDKs, and whereas the type 2 is a one-time stateless job which will be executing the remote Kubernetes cluster, and whereas the type 3 is a stateful function running as a long-lived Kubernetes pods exposed via REST API. And the life cycle, so managed by the application itself, and it's loaded and unloaded. It can be loaded and unloaded anytime. It depends on the application. Whereas the stateless runs as a Kubernetes jobs and terminates upon the completion of the job. And as soon as completes it, the pods also will be terminated. And whereas here the stateful job, it is initialized once and runs as a pod, and it is available until unless you remove it. And in the communication, it's definitely an in-memory communication from the main application to the function which is running inside the main application. And in the type 2, no live communication, application waits for the result. Whereas in type 3, it's a REST API over HTTP. And scaling, you need to handle manually. If in case you want to run multiple instance of the function, you need to create a threadings and all. Whereas the scaling for jobs is not applicable, and auto scaling rules configurable at deployment time for the type 3, which is a stateful job. The fault tolerance depends on your application, and whereas the fault tolerance in the jobs is handled by the Kubernetes, and also the fault tolerance is handled by the Kubernetes for the stateful deployment. So this is one information I want to give related to the function bank. So we'll check the how this is implemented, how we have to call it, how do we have to activate it. So in our previous video, we have discussed the directory structure, where you go to the service grid examples, and if you go to our function usage demo, so you will see 4 folders: deploy, run, functions, nodes, and spec. So this nodes is nothing but where our Python file will be there, which is of agent code, and the spec file is about the registration files of these agents, and bash scripts for registration and all will be available in the spec folder. Deploy and run is the the JSON schema for a workflow. So we have a workflow where we call this agents, how we have to call it in, how they have to chain together needs to be will be defined in this spec function workflow specification file. So, and also we have a Streamlit app, and we have other scripts which will help in deploying, registering these workflows. And also we have a function folder where it contains the source files of the functions. So in this example, we'll discuss about, though this image is related to a behavioral workflow, but in this example, the structure remains same. So you have an bigger workflow, and in that you have two agents. One is in the green box, one is in this box. And in this green box, whatever we have is an the code generator agent, which will simply take the user input and generates the code and gives it as an output. And that output will be taken by the second agent, where the reviewer agent. And in this reviewer agent we have three functions. Those functions are deployed as a separate entity, and this agent code will tap onto those functions deployed as a either it is a stateless or stateful. So in our case, this code validator and the test runner is a stateless, whereas this test case generator is a stateful for a purpose of showcase. So we have two stateless and one stateful function. So here the code validator responsibility is to validate the code or add some if some many issues are there in the code, it will just try to correct it. And in the test case generator, it generates the test case, and test runner will run those test case. So here we are, to keep it simple, we have asked for we'll ask it for a function, and we'll give a problem statement and ask it to give a small simple function. So the simple function will be created by this, and that simple function will be passed to the second agent for a validation, test case, and running. So we'll get started with the files. So let me just go and show the deploy and run folder. The Jupyter notebook is here, which I've already opened, and we have a the workflow spec file. So in the workflow spec file, we have the workflow ID related data, the URLs, the URI of the workflow is available here with the name, version, release tag. And in the body, we have a what all two agents are there. So that will go into the note section. So we have two agents. One is agent code creator demo function, and one is a agent code reviewer demo function. So these are the two agent subject IDs. I'll tell you what is a subject ID, and they are of agent type. And we have given some temporary names within this particular spec file. And in the for a graph, we need to use this temporary name, that is node ID. And what we have given is the first agent is this guy, the agent code creator demo function, which is the first of the agent. Its output will go to the second agent. So this is a very simple graph, two agent within the workflow. So if you have a complex workflows, we have other videos for where we have created different levels of workflows, multi-level workflow, hierarchical workflow. So there we have created different sort of graphs, and if graph is not possible, how to create a dynamic. So you have to check the workflow videos. They are present in our YouTube channel. So you can just go and check those videos. So this is the workflow spec file, and then we have a registration files. Let's say this is a registration file. What it does is basically it registers this spec file with the API call, REST API call, and you can unregistering is available here. I'll not go in detail because these are already covered. And this is for deployment file. What it will do is it will create a it will register, though the registration is there. It will deploy one pod known as a workflow pod, which will be there in the workflow namespace. And that workspace, that pod will take care of calling the agents, taking the input, calling the agents, taking its agents output, and passing it on to the second agent. So all those things taken care by the workflow pod. So we have a Streamlit app just to check the input output coming from each agent, so which I'll not again go and explain the code here. So you can this Streamlit app is very simple. It's already discussed in several other videos. So let me just go to the next folder, the nodes folder, where two agent codes are there. Let me just open the agent codes. And the first agent code is a code creator. So here we have imported all the required libraries, the Agent SDK library, and this Agent SDK library is present in the Agent SDK library is present here. So we have agent tools and agent functions as well. This agent function library is used in the second agent, the reviewer agent. We are using the agent functions. So in our previous video for tools usage, we have used the agent tools library, but in current video we'll be using agent functions. So in this code creator, it is just like a very normal code. We have DSPy signatures are present. What we have asked is just to generate an function, and it has to give me an output of code, function name, and description. And the user input is user request. So user request will be sent, and code generation output, which is of this structure, will be extracted from the LLM. So this is the DSPy signature, and it's like basic things which I'll not explain again. We have a code creator agent class. It has a init and get muxer and one preprocess and on data 4 functions. These are all very important functions. So other functions are internal to the this class. In the initialization, we are doing an initialization by taking the subject and context. Subject will contain the registration file content. So whatever the registration we have done, I'll just show you that. So we have a spec file here and we have a registration file here. So whatever the contents of this files, right? So you will get it as a subject, and context is something related to, like, if you want to know, connect to the memory or anything related to any other components of AI agent grid. So all those will be passed via the context. So right now I'm not using the context anywhere, but yeah, so we will be using the subjects here and there. So in a later section, we'll see how to use the context. So we have a his module. So I'm using the his client. His client is nothing but basically human in loop system. If the agent wants any input related to its current task, it can ask the user. So user can give it. It's again REST API call, WebSocket calls. So you can send the output in the via WebSocket, and it can pull it, and then his client will continue the task based on the user's input, whether to process or not, or what is the right one. So such kind of things you can use it. But right now I'm using a his client here just to push the output to one place such that I can use it. I can pull it and I can display it in a Streamlit app. So right now, not don't worry about the his client. So we have separate videos for that to check how to get the input, how to process the input. We have separate videos for that. So in the get muxer, so there is no mux concept here, so it returns none. And in the on process, so whatever the task I get, I'm simply returning as an array of task, because it has to return the array of task. That's the pre-process. And in on data, so we'll receive this one task. So that is right now we have only one task, so that task will receive it and we'll start processing it. So we basically get the user request with this function that we have will break that uh, whatever the user request we have, right, the payload, the task, it will just break it into some 3-4 items, and that item I'm putting in registry. So it's in local variable. Right now I'm not using it much, but we can store it yeah, temporarily somewhere, like not in agent code. What happens with let's say if agent pod restarts, so all the history that it has created will be lost. So I can use this variable later on to push it somewhere, right? That push I have not put it in this video, but we have some other videos for pushing this content as a storage. We can push this content to the storage backends, so which can stay there, and anyone can access it. Any agents can pull it or push it or update it. So even whenever the agent restarts, it can basically pull the content from there. So for that reason, I have kept this variable. So the main job is execute worker. What it does is it takes the user message and the model name, and it executes it. The DSPy signatures will get activated here. It will call the LLM. The DSPy signatures will be used. What is the input, what is the output, what is the prompt message or a system message. So it will execute that, and we will get the result. And that result, I'm just passing it into the as a output to the second agent. So where I'll push the user request, what is the code, function name, description. These are the 3 outputs of the current run, and that I'll be passing it to the next agent. So let us see the next agent. So the next agent again will get the input. Again, it has some init functions, and in the init, I have some certain things like similar to what I have done for the tools. I'm doing it for the agents here, so that functions here, where in the agent registration time, So in the agent registration, integration, and subject functions, I have kept 3 functions. So I'm going to create I'm going to tell that the agent, hey, use this content present in the subject, which is that nothing but the JSON schema. So you just initiate that, you just use those functions so that we can use it in our code. So that's what we are doing right now. We are taking the subject functions, and from that we are just trying to extract the function ID, and I'm just adding it. So agent function dot add, this agent function is created here. So agent function requires a function registry URL, a unique parameter, a executor ID, and number of workers. So what is this function registration URL? So that is provided in the JSON spec. So you have to go to persona, config, parameters, and here function config is there. So in our tools, we had tools config, and here we have function config. So this is the function registry URL, which will be coming from the EUNI file, and we have a unique parameter. So anytime you run this agent for the first time, you need to give a new unique parameters. So don't forget to give this unique every time the agent runs. Means when you have registered the agent and when you start, right? So it uses that unique parameter to club all these versions of functions. If at all, if in case you are restarting the agent, if you have not done any code modifications or any functions modifications, then you don't have to change it. If in case you have done any modifications in your functions code, or you are re-registering it, or you pushing the latest file or something like that, right, of the functions, then you need to change this unique parameter. This unique parameter is basically tied to one set of function IDs. So anytime with the function ID changes or a zip file changes, let's say you are not changing the function ID, you are returning the same version, but you have updated the zip file. So to pull the latest zip file, you need to change this unique parameter. So AC31 will be tied to 2.225, 2.225 of the test generator, and 2.25.0 of a test runner, and those zip files are pretty much stick. So it has a one-to-one mapping. Even though you upload again a zip file, it will not take the latest zip file, it will take the old zip file only, because it is tied to the unique parameter. The structure, the functions architecture is such that, so even though you push a latest zip file, or a you are changing anytime the registration of the function, you need to create a unique parameter. So unique parameter is required. So right now I'm giving an AC31. The executor ID, is one unit where they are responsible for executing this function. So I have we can create n number of executor ID, be it based on team, or be it based on the client or anything. So you can create several executors, and when you are creating executors, you will tell it how many cores this executor has to run, where it has to run, all those details you will be giving when you are creating executor. Right now the executor is already created from my side, and I will be using this particular executor name, executor ID, and this executor ID will execute these functions within its domain or the namespace. So basically these functions will be running within the executor. The executor will take care of how to pass the input to these functions, how to get the output, and how to pass the output back to the caller. So all those things will be taken care of by the executor. So, and also number of workers. So since if you, in case you have many several functions, so you require a multiple workers there. So how many multiple workers you want? So right now I'm creating an 8 number of workers. The LLM block ID, so the block ID that these functions has to use, and the API key. This API key is basically for the agent selector. If in case you are using some agent selector SDK, so we have agent selector SDK as well here, agent search SDK. So this agent search requires a LLM. So for that reason, we have this API key and the agent select LLM. So this is the function config. These are the functions we have again on model as well. So we have a one model which is OpenAI. The LLM block ID is OpenAI, and this is the model of the model of the GPT, and this is the OpenAI colon. So we use this as to say whether it is OpenAI model or any other model. And we have a LLM parameter. In the LLM parameter, we have passed the API key as well, which we'll use it for running the agent, if in case agent requires an LLM, or we'll pass this same thing to the functions as well. So let's go to the second function, the second agent code. So where we have initialized the agent function, and that we have taken all those details from the JSON file, and then we are creating the we are to that object of agent function. I'm just adding those function IDs, the 3 function IDs we have added into the JSON file. So basically right now this agent has access to only those functions. It will not have access to any other functions, whether let's say your registry has several, like this is the registry, and if this registry has several functions, but it has access to only this agent code will have the access to only those 3 agents, because we have done a addition here. So now once we have done addition of the functions, then then again his client, again I'll be using it for just for displaying the output of each agents only. And we have a mux function that it's written none, so I don't have any mux operation in the pre-process. So I'm just checking whether code variable is present or not. If not, I'll return none. If present, then only I'll move forward to the task. So right now it is not required, this is not required. So, and in on data function, basically I'll get the input. From that input I'll get job.code and function name and a description. So once we got all those things, I'm constructing an input out of it, which is nothing but input data. And here I'm having on temporary agent function dot call. So I'm calling the agent function. So we have the agent function here, add is for adding, and we have a call for calling one particular agent. So right now I'm directly hard coding which is that agent I want to call. So right now saying I'm asking it to call the code validator. So since I have the code, I want to validate the code. So first is the code validator, and what is the input data. So whatever the input data that we have constructed here, I'm passing it. And what is the parameter? So the tool model, the tool model is the thing, but the model that the function has to use if in case it is using a LLM. So tool model is required, and any other parameters are if in case you are sending any parameters in the registration time, custom parameters. So I'm just basically passing it here. So this selected tool model is nothing but whatever we have created the model here, this particular model, right? We are mentioning here as a LLM block ID, which is nothing but this. So this is same as this particular LLM block ID. So now this becomes the model that goes to tool model. So next we have a second function, the output. Once we receive the output, we call the second function. For the second function, we will simply pass on the output of the first without doing any modification. If in case you want to enrich it, you can definitely enrich and send that. So the function call test generator, this is the function ID. This self.test generator is nothing but function ID here. So code validator, self generator, they are nothing but the function IDs. So I'm sending for the second function, which is a test generator function ID, which is a stateful. This is a stateless, so it creates a Kubernetes pod whenever it is about to call, right? So it will create a Kubernetes pod, and whenever it is trying to create a stateful function, it creates a Kubernetes deployment. So definitely when the pod of this job or a deployment creates, it takes some time. So our the library will take care of waiting for that pod to appear and ready for inference, and then it will do a inference with those functions. So inference here is basically the call in the API. So the second function is also called, and we are passing some parameters that is needed by the second function, and the second function output will go to the third function. And here I'm running a test runner, and I'm passing the result 2, and I'm passing some parameters. So the final output is result 3. So that is what I'm returning from this particular agent. So this agent output will come back to the workflow engine, and workflow engine will pass it on to the caller. The caller is the thing, but right now our Jupyter notebook. So these are the agent code. So let us go to the agents, the functions code. So functions demo. So let me go to the functions, and in that functions we have a 3 functions here: code validator, test generator, test runner. Let me open each. So so in the code validator, so in tools again we had a similar structure. So there the code was the folder name, but here it is a function. So function has to be the folder name, and in this function file you have a code folder, and in that function.py and requirement.txt is there. So basically sorry, this is, it's not a function, it is a code only. So code folder has to be there. In that code folder we have to have a function.py and requirement.txt. Since it is a Python base, so a requirement.txt has to be there if in case you are utilizing any imports. So requirement.txt is not that mandatory until unless you require if you want some new pip installations, then only you have to give it. So the function.py, the name has to be accurate, so no, not even a single character miss. So what that code folder will be zipped to is a function.zip, and a function.json is required. This is nothing but again a registration file. So let me just open this registration file, and yeah, so I have a zip file here, which is a thing, but it contains the code folder, and that JSON file and this zip file together we create a one bundle, which is the thing what I have given as a code validator as a zip name, and we'll upload this to the function registry. So similarly, we have to do this for other guys also. We have a code folder that you need to zip it as function.zip. This name has to be accurate, function.zip, and function.json has to be there. They are bundled together to form one particular zip file. So this name could be anything. So next we have again a test runner. Again, you have a function folder, code folder. In that function.py requirement.txt, they are zipped to form a function.zip, and JSON file and zip file together forms one bundle known as test runner.zip. So all these three zip files we need to upload it into the registry, and we have an endpoint for it, which I'll show you in later section. So right now let us go inside the function. So I'll open the code validator function. So code validator function has a one class which is known as AIOS policy rule 1. So this class has to be, the name has to be this one only. You don't modify this name. And so it has an init function and it has a eval function. So it has two functions, very init function and eval function, whereas the tools had a three functions in init, execute and execute command. So here it's only init and eval. So other functions are internal functions. So in the init, so you are passing a rule ID, settings and parameters. These are our initial parameters. So I'm just, you can create any initializations if it is required. And if you are passing an API key, I'm just creating an OpenAI client. But if you are passing any other API key, let's say Gemini or something, so I have handled it in the bottom. So in the eval, so I'll get a parameters, input data, and the context. Context is if in case you want to retain something. Right now, the code validator is a stateless, so there is no use of retaining anything. So there is no use of context here. But if it is a stateful function, the context, you can store something if in case you want to store it. Let's say you want to store any intermediate results. So that even this pod restarts, right? So you don't want to lose a context. So in such cases, we'll be using certain primitives present in this context variable, which is same as in the agent, whatever you will get as a context, right? So in the agent also you will get in the class you will get a context. So similar to that, we will have uh, the context here as well. So the parameters, in what we do is from the input data we extract, this is the code validator. So we are expecting code or description and function name. So we are just extracting it. And in the parameter section, if you have a tool model, that's what we were sending. So in the parameter section, we were sending a tool model. So if the tool model is available, so we'll have calling a create client, which is similar to what we had seen in tools code as well. So we are just creating the client, creating the client here, and then using that client, and I'm doing an the actual inference. Basically, I have a small function here. What it does is, you are an expert Python code reviewer. Analyze the following Python code and provide a correctness check, optimization suggestions, and optimized version of the code for incorporating your suggestions. You can use a dspy as well. If in case you're using a dspy, in the requirement.txt you have to provide the dspy. So this is the structure of the output that is needed. So is valid, issues, optimizations, and optimized code. So this is the output structure of this particular LLM call. So if it is a Gemini, you are using a Gemini client, and if you are using a OpenAI, you are using an OpenAI client and the respective API calls. So that will be returned from this particular function. The validation output will be going from this particular function as a code validation key, and this is the input data. So this is what we are returning from this function. So let me show you the second function, the test case generator. The test case generator, again it's same, the initialization is same, code structure is same. So basically you have a tool model and it will create the client, and if the code is not present or if function name is not present, it will throw some exceptions. Then it generates the inference. So inference here is with respect to LLM. You are an expert Python test engineer, and we are giving some we are asking it to give a code coverages for different scenarios, and it will provide a test case like this. So function name, test cases, so list of test cases, a description, what are the inputs and what is the expected output. So those things are required as an output from this LLM. So we are giving that structure so that the LLM produces that structure, and we are just using the client.chart completion here. So I can yeah, so right now, if in case you have used Gemini, same thing, you need to copy paste this particular piece of lines of code. So so the output of that will be passed as a test cases in the test case key from this particular function. And let's go to the third function. So the test case generator runs as an the stateful function. This will run as a jobs. So the test runner also same. So you have function.py. Its structure is also same. Here there is no LLM call, so it just runs this functions and test cases within the Python environment. So we are just extracting the inputs and then do the compile of the code and the what is the policy code and the exact three things we are passing it to the compile function, and it will take care of running the running this particular the test cases and the input of the test cases. Everything it will get run inside this compile. And sorry, it will give the compiled code, and then we are going to run the test cases. The test cases is present, the run test case is present here. So if the test passes, we will say test status is okay, description, inputs, expected output and actual output. Expected output is given from the previous stage, the actual output is from this particular stage, and also whether it is passed or not. So we have status error and status okay. So if something is missing, then we will get status errors. So that will be clubbed now. So all the test cases will be run, and then we are trying to get how many passed are there and how many total test cases are there. And with that, we are creating a small summary here. So test result complete output is here, test input is here, test out result is here, and the summary of it, summary, total, passed, failed. So these three items will be there in the summary. So this is the final output that we are sending from this particular function. So let us go. The functions are created, and sorry, the function code is explained now, and I'll just show you the registration. So the build.sh will build all the zip files required. So basically what it does is, if in case any function.zip is present, or any code validator zip is present in the first folder, code validator, it removes it. Then it zips one by one, it zips the code folder to function.zip, and then it moves this function.zip one steps back, and then it will try to zip the code validator zip with function.json and function.zip. So similarly it does for all the three guys, and at the end it provides the bundled zip file. And then upload file, what it does is, it basically takes those zip files for environment variable. It will load the environment variable for the URL upload URLs, and then it will do the post of those zip files using this particular endpoint. So this is the endpoint. The function upload is the endpoint, and what is the file? This is the zip file, and it needs to be pushed into this particular URL with this file. This is the URL, and these are the file details, and we need to push it into this particular path. So the env files will be present as a so it is not visible here. So env file is available. So you have .env.template, so you have to duplicate it, and you need to replace certain IDs, IPs, all those things you need to replace it. So this is the upload function, and let's go to the Python notebook. So we have explained you the agents code, we have explained you the functions code and installations code, the uploading code, and also we have similarly for codes for agents as well. So in spec folder, we have a spec file. Will registration is present here, and registration file sh file is present here. And this is for deploying. What deploying does is, the registration is simply dumping into the DB, validating the JSON schema and dump into the DB, and deploying is nothing but creating an object, the pod out of it, deployment out of it. So the deployment agent will do the deployment of this agents in agents namespace, and remove of this agent is nothing but basically it removes the deployment of the agents. So let us run one by one. We'll start the demo. So first we need to register the agent. So let me register the agent. So it has registered two agents, and then we have to build the dockers. So we have two agents, so we have to build two dockers. So bash file is present for that, so let us run this bash file. So it basically builds and pushes the docker to the local registry that we have in our cloud. So it's just pushing to the local registry. So once docker building is done, then we'll be zipping the the codes of functions. So that I'll just run it, so that once this building is over, it will build the so every time you have done some modifications to the agent code, you need to build it. But every time if you make any modifications to the functions code, you need to build the zip file. So, and also you need to push the zip file once the zip file is built and pushed, but it will not be pulled by the current running agent. You need to create a new agent itself if in case you want to pull the latest zip file. So let us see whether this file is, no, it is still taking time. The building is taking time. Now that the building docker building is over and it is already built, also the zip file is also built, and let us run the upload. Yes, it has uploaded the all the three zip files. It has uploaded and registered. As you can see, when we are creating the functions, so the functions has this particular JSON registration. It has function name, function version, function release tag. In tools, the version and release tag didn't had any weight, so we were not using those. But in functions, we have weights or equal weight for function name, version, and release tag. So this is important. This creates a unique URI for the function. And we have a function metadata and function search description. In it, the description of the function, you need to what is this function does. So that description you need to provide here, so that if in case any LLMs wants to use and understand this function details, it can use this description. You have function tags and function type. It is a policy type. Function man page, function code. You don't have to give a code here right now. Since we are uploading the zip file, the code will be automatically replaced here. Like, so as you can see, function code, you don't have to give anything, you have just left it empty. So here the when you're uploading it, right, it will take care of pushing that zip file, the bundle zip file, and giving it a temporary name, and update this particular piece of information, function dot code, sorry, function underscore code. And policy rule URI, if in case you are creating any policies for pre or post processing of the output of this function, you can give some policy rules. And function settings, in this settings, only log level is only one variable, and its schema is available here. So you need to provide the schema and also an initial values. So if in case you are not passing any settings and parameters from your function, sorry, your registration, it will take basically these values. So the settings and parameters present here, and schema is present here. So let us see the settings schema. So it has a title is settings, and it is a type of object. And additional properties, yes, it has additional properties. And in the properties section, you have a log level, which is of type string, and it can have only 4 values, and default is info, and we are passing info as the log level. So this is the function setting. And in the functions parameters, again, the similar structure is of object, and it has a only tool model as a code, and type is a object type. So let us see what I am passing in function parameters. So right now I'm passing nothing, but when I'm doing an inference, I'll be passing the object. So that's what we have done here. So in the initialization, so whenever you do a add, so it will do a basically pull those whenever you do a add, it will pull the zip files bundle. It will pull all the details related that agent, and it will keep in within its code, its access all the zip file will not be pulled, sorry, the function the functions related information. Where is this function, what is the detail, what is the input schema, output schema, all those will be pulled, and it will retain within this self.agent function. And if in case you are making any mistake in sending the variables, it will right away throw it here. So right now here we have a input data and parameters. So parameters is what the schema should be. So right, this is the parameter schema. So the parameter schema is it has one tool model, and rest all it doesn't have anything, and the tool model is of object type. So I'm again not explaining what is the structure inside, what are the subkeys, because it's, since it is very complex, I'll just leave it like object, and whatever, it is not basically a loose type check, so it will not do any check. It has to be just object. So within that object, what are the keys, it will not check, it will not be strictly checking it. So basically what I'm passing is nothing but the in the tool model, I'm just passing in maybe a string or a selected model. So I guess selected model is could be a string here. No, sorry, the selected model is an object here, and the object is nothing but basically you are create the whatever the during agent registration. So this is what completely passed. So this becomes the model of one. So that's what I'm seeing in the code, that's what we are passing here. So if type is LLM, selected tool model is not a dict, it will create a dict, and what is that, it is pulling. So it is basically taking the model from the models. So this is the whole content, this is the whole content will be passed. So it's the object type, and what is the input schema and output schema. So input schema is nothing but, so in the eval, the parameter section we have seen, and this is the input data, and this is the output, this is the output data. So what should be the schema of this and what should be the schema of this is defined in the input schema, the function input schema and function output schema. In the function input schema, so we have a properties known as code, function name, and description. These are the function schema of the first function. So code is required, function name is required, description is required. Code is of a string type, function name is of a string type, and description is of a string type. So required is code and function name is definitely needed. And example, so we are just given an example here. So this is the input schema, and in the output schema, so the properties we have, it should have a code, function name, description, and code validation. Code validation is the object, which is the output of the previous. So this agent, and it has is valid, issues, optimizations, optimized code, etc. So that is coming from the function code. So what you can see here, is valid, issues, optimizations, optimized code, these are the output from the function one. So that's what the structure has, that those keys representation. So is valid is boolean, issues is array, optimization is an array, and optimized code is an string. So this is the output schema of the function. So basically you are defining the setting schema, parameter schema, input schema, and output schema for the function, so that whenever the agents are passing the input to the functions, so they understand this, they will check the types of each, and if there is an issue, they will directly flag it. So this is the registration file. So right now we have done the registration of these functions, and if you want, so those registrations are done now, and let me do an deployment of the agent. So agent talker was built, agent is registered, but it was not deployed. Let me run the agent. So two agents have started. So let me just check in the pod names, agent namespace, their container is creating. So let me just, the container is taking time, so let me take the second agent. Yeah, so the pod is created. So both the pods are running now, and this is the executor pod. This is something related to the agent grid. It has 3 containers, whereas this pod contains two containers. So one in that is Redis. Redis is used for communication between this executors and this agent code, and the one other container here is a agent code itself. And here these executors are responsible for passing on and or any health checks related. All those things will be put into this executors. It has 3 containers. We have already explained what are those 3 containers in our other videos, so I'll not go in detail about those executors. So now the agents are deployed, and now I need to do a workflow registration, because this, though the agents are running, they are not tied together, how they have to communicate. So I require an workflow, and details related workflow I'll not explain again. It is there in our other videos of workflow, so please check what the registration workflow will do, and how what the deployment of workflow will do. So I'll just execute them. So registration is done, deployment of registration is done. And if you check this workflow namespace, you will be seeing on pod, which has run just 5 seconds back, and this the name of that the workflow. It has created an pod in the workflow. So now this will be responsible for getting the inputs and calling each agents one after the other. So let us run the input. So we have Streamlit app also. If you need, you can run it. I don't require it right now. So let me run the workflow input. So in the workflow input, let me just show you what I'm sending. So in the workflow input, so I'm asking it to you have two examples. You can check two examples. Right now I'm asking it to user request is the input. Create a function for adding two numbers square root. That is, if I send 4 and 9, sum is 2 plus 3 equal to 5. It's a simple, very simple function. It does a square root of individual inputs, and it does a sum of it. So this is my the JSON data that I'm passing to the API. This is the API slash API slash execute for executing of the workflow, and this is the workflow URL, and this URL is what we are collecting it here. And the URL is nothing but what, whenever you start a workflow, this is the pod, this particular pod service is running in this particular IP and port. So this is what we are collecting it, and to this IP and port, and we are doing an slash API slash execute to run the inference. So this input will be passed to the workflow manager. Workflow manager or workflow engine will take care of it. Understands to whom to send this input, because it has uh, the workflow the workflow manager knows the workflow spec. I have to close it. So workflow spec is already known. So the first is the a code creator agent, and second is the code reviewer agent. So it will pass the input to the code creator agent, and it collects the output of that code creator agent, and then it passes to the code reviewer agent. So let us run one input. So I was trying to log the second agent. The first agent I have not logged, so it will create some code. Yeah, so we got the agent input for the second agent. So job inbox is the input is coming to this particular agent. So it got already the codes. So here, yeah, before that, I just want to show you something. Maybe here, yeah, 30 seconds back, a job is created. Kubernetes job is created because first is the status function. So a job is created, and job is completed as well, and then it creates the second maybe the second deployment is already created. Since I have not changed any names, right, so the deployment is already available, so it has not created the second deployment. And the reason for that is our unique name is the unique name, right? So the AC31. So this AC31 might already exist. So let us see. Yes, the AC31 exists. It started 26 hours back. So since this deployment is already created, it will not create the new deployment. That is, the second function was a stateful, which is a Kubernetes deployment. It will not create that. It was already available, and it created a few seconds back. You would have seen there was another job. So that was the third job, the stateless. So for stateless, it will create a Kubernetes job. Once it is done, it will evict. So the pods will evict. The deployment will be, the Kubernetes job will be cleanly removed. And if it is a deployment, it will stay there. So since um, any agent, let's say if it is using this particular function, right? So any agent can tap on. So that's why this function exists. So, and also it is a stateful. So stateful, you need to have states, right? So that state will not be evicted. It will be available. So if even case when you are running for the second time, it can use any states. If in case the second function requires any state, like what was my previous output of this particular task or something like that, right? So that can be stored here. Whereas in job, it is like fire and die. So once it that completes its output, its output will be sent back to the agent functions, and it will die. So so this is about the pods. So let us see the outputs. Yeah, this was the input, and then preprocessing is called, then calling code validator 2.25.stable, then calling a stateless function code validator 2.25.0 stable. As this was a job name that was coming, and then the job is executed. The job is gives the output. This is the code validator output, which has a code folder, and it has a code validation key, code key, and optimizations key, and few other things maybe. So Yeah, so this is the output of the code validator. Now once the code validator output has come, so basically you again you have to do some checks whether the code validation has executed or not, if in case any exceptions are there or not, that also you can check, but in my code I have not put that. And the second is a calling a test generator. The test generator is a deployment, creating deployment, uh, creating this deployment, but this deployment is already available. It is a stateful function, so that's why you are putting in warning here, failed. Because the deployment is not created, it has failed, but because the deployment is already available, calling the stateful function, and it creates it calls the stateful function, and stateful function will execute it. It runs it takes the code and the function name and all those as an input, and it validate it generates the test code. So the test code is created here. As you can see, there are some test codes. So yeah, there is a test code here. Let's say test cases description, 2 perfect squares, expected output is 7, and inputs are nothing but 9 and 16. This is the description is 2 perfect squares. So we have again some more, the expected output is 5, and so sorry, this is the second test. We have a mix of 0 and positive number, so expected output is 5, input is 0 and 25. Then we have third test cases. Similarly, we have total 5 test cases. So this test case is generated from the stateful function. Then it is calling the test runner, which is the third stateless status function. So the status function is created, and it will implement the running of those functions. So you will not be able to see the output of this unless you just try to log those pods output immediately. But if you want the output of those pods, you have to just, as soon as they start, just take it and go to the policies namespace and just do kubectl logs. Or else we have other way of monitor the you can, we have a low-key integration as well. We'll again explain the metrics videos. So you can go to if you have the pod name, right, what is a pod name? So if you have that pod name, you can go to our low-key and you can check those logs as well. So right now this third stateless function is also executed. It has run the test cases, and it has given some summary at the end. So let us see the output. So here is the complete output. So these are the two agents. This is the first agent's output. This is the second agent's output. In the second agent, we have a code validation summary. So in the summary, passed, all the 5 test cases are passed, test inputs and test results is also present here. So this is the function usage. Basically, functions are getting deployed in the policy namespace of the Kubernetes. So stateless jobs are created, stateful functions are created. If the stateful function is already available, it will not recreate it. And even though you have updated the zip file, you have pushed the zip file, this stateful deployment, it will not pull the latest zip file, because that pod is already created, the deployment is already created. It will not re-pull the zip file. If in case you have done any modifications to the zip file, you better have to store it in a new name only, and also you need to change this particular unique parameter. So if you don't change the unique parameter, it will try to reuse the same old stuff. So we have we created the function. So we have given the input, we got the output. Right now I'll try to remove those. So to remove, you can click all this. So it is a removing of the workflow and unregistering of the workflow, and then removing of the agents and unregistering of the agents. Since it's a demo code, I'm just keeping the state of the Kubernetes clean. So as you can see here, the pods are evicting. So there is no pod of the agent code as well. So these are the functions, the demo we had. I hope you liked it, and uh, please watch our previous video of the tools, as well as the this functions and few more videos, function video, and also we have few more videos lined up for the ServiceGrid. So thanks for watching, and